For this next one, we're supposed to do polynomial division. Let me just remind you how regular division works, because polynomial division and regular division are pretty much the same thing. They work the same way, at least. So if I took a number like 7, and I wanted to take some big number like, I don't know, 315 or something, I don't know, just picking something, I would say, okay, well, how many times does 7 go into 3? No times. How many times does 7 go into 31? And I'd say 4 times. And then I'd multiply that 4 times 7, and I'd get 28, and I'd subtract. 31 minus 28 is 3, and I'd bring this 5 down, and I'd say, okay, well, how many times does 7 go into 35? And I'd say, okay, well, another 5 times. 5 times 7 is 35, and I'd subtract that, and I have a 0. And that's how I got 45. So that's what we did back in grade school when we learned how to divide things. So now I'm going to do the same thing with this polynomial. Okay, hopefully I have enough space for it. We'll see what happens. So I'm going to write out this top thing, the denominator or the numerator, all under this, and I've got x to the 4th plus 3x cubed plus 4x squared minus 2x plus 1. I'm going to divide the whole thing by x plus 2. Well, how many times does x plus 2 go into x to the 4th plus something else? I'm going to need an x cubed there, because when I multiply x cubed times x plus 2, I'm going to have x to the 4th plus 2x cubed. And then, just like up here, I'm going to take that same thing and subtract and see what I get. Well, the x4's go away. 3x cubed minus 2x cubed is just a 1x cubed. And just like over here, bringing that 5 down, I'm going to bring this plus 4x squared down. Okay, let's see what we've got now. So how many times does x plus 2 go into this? Well, I need an x to the squared, an x to the 2 power. So if I multiply x squared times x plus 2, I have x cubed plus 2x squared. And again, I'll subtract this whole term, just like I subtracted the 28 or the 35 up here. The x cubes will go away. 4x squared minus 2x squared would be positive 2x squared. And I just keep on going. Here I've got a minus 2x that I'm bringing down. What do I need to multiply x plus 2 by to get rid of this 2x squared? Well, I need to multiply by positive 2x. 2x times x is 2x squared. 2x times positive 2 is positive 4x. And I'll subtract this whole thing. The 2x squareds will go away, and I'll have a 2x minus a 4x, so I'll get negative 6x. And I'll bring down this last term, which is a plus 1. Let's see what I've got. I'll need to multiply by negative 6 to get rid of that. Negative 6 times x plus 2 is negative 6x minus 12. Okay, you can see it doesn't go evenly like it did up here. So I'm going to have some remainder. So let's subtract this whole thing. Negative 6 minus a negative 6x. Negative 6x minus a negative 6x is 0. But here I've got 1 minus a negative 12, so I've got 13. Now what do I do when this remainder isn't a 0 like it was up here? Well, I say this is plus 13 over whatever my divisor was. My divisor over here was x plus 2. So this is my answer. So when I divide this out, I get x cubed plus x squared plus 2x minus 6 plus the quantity 13 over x plus 2. And these two expressions are exactly the same. Now what happens when I have something like example B over here, where I want to do the same thing, but I've got an x to the 4th, and I want to divide it out by x minus 1. Well, I can start the same way I did before. I need an x cubed here, So I'll multiply that through, and I get x to the fourth minus x cubed. But then when I subtract, I have an x cubed here. And I need to bring something down. Well, what am I going to bring down? Well, this really has 0x cubed, or a 0x squared, and a 0x, and a 0. So you could have as many zeros as you like in those terms. Just like if I divided out by 300 instead of 315, I'd have zeros in those places. Okay, so now I'm going to bring down this this 0x squared, and I just have a 0, x cubed plus 0. And I do the same thing. Well, I need to multiply by an x squared. And I get x cubed minus x squared. And when I subtract, the x cubes go away. Minus a negative x squared is a positive x squared. And I have something that looks like this. Again, plus 0. So I need to multiply by x again. I have x squared minus x. If I subtract that whole thing out, the x squareds go away, and I'm just left with a minus a negative x, which is a positive x. I bring down this last term, which is again a 0, and I need to multiply by 1. So 1 times x is x minus 1. If I subtract that, the x's go away, and I'm left with a 1. So I'm left with positive 1 over x minus 1. So my final answer here is x cubed plus x squared plus x plus 1 plus 1 over x minus 1. And those are two examples of polynomial division.